Let's all jump to, this is the last video, the last page, number 58. It does say find all the zeros, root solutions, answers on the following. It's not going to say that on the final. I just am emphasizing here that the word zeros, roots, solutions, answers, it all means the same thing, even x-intercepts. So we want to solve this guy and get an answer. Now this is a cubic trinomial, so you can't really factor it per se. It's not a quadratic. You can't change it to a quadratic. So we need to use the rational root theorem, or we could graph it on Desmos. So be very grateful, guys. You are going to be able to use Desmos on the final. We've never been able to use a graphing calculator or the Desmos app on any test. This should really, really help you out a lot. Why? Because if they want all the zeros, all the answers, we could graph it on Desmos. Let me graph it right here. On Desmos, you type it in, x to the third plus 6x plus 20. We could have put y equals in front. It doesn't really make a difference. It shows you, you can't even see the entire graph. But for sure, you could see that it definitely crosses at -2. So what does that mean? That means that one answer is -2. That's an answer. That's a solution. So let's keep that in mind. X equals -2. And again, that's from the Desmos app. You just type it in exactly the way it is and find your x-intercept, because an intercept is the same thing as a zero or a root or a solution. So there's one solution, but they say find all the solutions. So what I would do is plug in your solution, -2. I mean, x equals -2. Plug that in into synthetic substitution, and the coefficients will be 1 on the x to the third, 0 on the x squared, 6 on the x, and 20 as the constant. So as you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. -2 times 1 is -2. As you go down, you combine. 0 plus -2 is -2. As you go up, you multiply. -2 times -2 is +4. As you go down, you combine. 6 plus 4 is 10. As you go up, you multiply. -2 times 10 is -20. Now, that does not surprise me that my remainder is 0. Why? Because I graphed it on Desmos, and we saw that the x-intercept was -2. So we plug it in. Of course, your remainder is going to be 0. So this is our depressed polynomial now. Okay. So our depressed polynomial is, let me write it out, 1x squared minus 2x plus 10. If you do go back to the Desmos app, and we take a look at that graph, it only crosses at 2. What does that mean if it doesn't cross anywhere else? That means that the other answers are going to be imaginary, okay? So going back, we know that this is not factorable, and we know that we're going to end up with imaginary answers, which means that since it's not factorable, we're going to have to use the quadratic formula. A value is 1, B value is -2, C value is 10. Quadratic formula is -b plus or minus the square root of b squared minus 4c all divided by 2a. And of course, when you use this, please use parentheses, -b plus or minus the square root of b squared minus 4 times a times c all divided by 2 times a. So let's plug in our b value of -2 right there and right there, the a value of 1 right there and down there, and the c value of 10 right there. So as we work this out, the minus minus becomes positive. You have a +2 plus or minus the square root of, this is 4, and this is -4 times 1 times 10, that's -40. So you really have 4, take away 40, which is what? -36. And it's all divided by 2. So when we look at that radical value of square root of -36, what is the square root of -36? 6i, right? So we really have 2 plus or minus 6i all divided by 2. And we could take this division of 2 and split it. Do the 2 divided by 2, which will give you a 1. The 6 divided by 2, which will give you a 3. So your final answer is 1 plus or minus 3i. So those are your additional answers. So even with the Desmos app, you can't get your complete answer. It'll only give you the real answers when you graph it. And once you have that real answer, you could at least plug it in with synthetic substitution, That way you could get your depressed polynomial. That way you could use a quadratic formula to get your other two imaginary answers. Okay? So what are your answers? The multiple choice, you're going to need this answer, -2, and also these other two answers, plus or minus 3i. X also equals 1 plus or minus 3i. So those are a total of 3 answers for that cubic function. How many answers are we going to get on number 59? 4. Now, maybe some of those answers repeat, they're duplicate answers, but we could get a maximum of 4 answers. Maybe some are real, maybe some are imaginary. So let's begin by graphing this guy on Desmos to find out at least some of those real answers. So here's my function, my quartic function typed into Desmos. As you could see, you could put y equals. You don't have to put the y equals. It still picks it up as a function, a quartic function. And when we look at where it crosses the x-axis, it's crystal clear that we at least have 2 real answers. One real answer is right there at x equals -2. The other real answer is right there at x equals +2. Okay? So it was a 4th degree, so we need to find the other answers, which might be imaginary or they might duplicate. Let's check it out. So once again, we said that the 2 answers so far are +2 and also -2. So let's use one of them to make this a depressed polynomial. So we're going to plug in, let's do the top one, 2. If we plug in 2 right in here, let's do a list of the coefficients. We have 1 on the power of x, or the coefficient of 1 on x to the 4th. We have the coefficient of -6 on x to the 3rd, coefficient of +6 on x squared, coefficient of 24 on x, and the constant -40 at the end. So as we go down, we combine. So 1 plus nothing is 1. As we go up, we multiply. 2 times 1 is 2. As we go down, we combine. -6 plus 2 is -4. As we go up, we multiply. -2 times +2 times -4 is -8. As you go down, you combine. You end up with a -2. As you go up, you multiply. 2 times -2 is -4. As you go down, you combine. 24 take away 4 is 20. As you go up, you multiply. 2 times 20 is 40. And again, no surprise that that the remainder is 0. Of course, the remainder is 0 because we went to Desmos and we found that the answer, one of the answers is 2. So here's a depressed polynomial function. Or you could just plug it in again. Plug in the next answer that you had, which was -2, using these coefficients on the depressed polynomial. So let's now plug in the -2 right in there with the coefficients, depressed coefficients of 1, -4, -2, and 20. Here we go. Carefully. 1, -4, -2, and 20. Okay? So as we go down, we combine. 1 plus nothing is 1. As you go up, you multiply. -2 times 1 is -2. As you go down, you combine. -4 plus -2 is -6. As you go up, you multiply. -2 times -6 is +12. As you go down, you combine. -2 and +12 is 10. As you go up, you multiply. -2 times 10 is -20. And again, the remainder has to be 0 because that was another answer. So after looking at these depressed coefficients, now we'll have a quadratic trinomial, x squared minus 6x plus 10, that we could actually solve. All right? Now we can't factor, split, and solve. If we were able to factor, split, and solve, we'd end up with real answers, and you'd be able to see those x-intercepts on the Desmos app when we graphed it. So you're not able to solve, so you're going to have to use a quadratic formula again. X equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So the b value is -6, the a value is 1, the c value is 10. -6 for b, -6 for b, 1 for a, 1 for a, 10 for c. When you do this math, you have a positive 36 right there, minus 4 times 1 times 10, that's 40. So 36 minus 40. What we have right now is a positive 6 plus or minus 36 minus 40 is -4, all divided by 2. What is the square root of -4?
2i.
So we really have 6 plus or minus 2i, all divided by 2. So we're going to reduce all 3 terms by 2, or you could separate that denominator of 2 to each of them and divide. So you could separate them and say, what is 6 divided by 2? That's 3. What's 2 divided by 2? That's 1. So your answer is 3 plus or minus 1i. Or you could actually just reduce it all by 2, and you'll get the final answer. Here we go. So our final answer is 3 plus or minus I. That's the final answer there. That means that there's 2 imaginary answers to this quartic equation and 2 real answers. The real answers are x equals 2, x equals negative 2. We got that from the Desmos app by typing this in and finding where they cross the x-axis. Those are real answers. And we only saw 2 x-intercepts, which means that the other 2 must be imaginary. So we use these answers to get our depressed polynomial functions, and then use the other answer to depress it again, getting a quadratic, then using the quadratic formula over here to get our final 2 imaginary answers. So 2 real, 2 imaginary. Let's move on to number 60. Again, we want all the actual answers, real and imaginary. So we want all the answers. We're going to begin by graphing it on Desmos. As you can see, I typed in the cubic function exactly the way it is. You could put y equals and then write the whole cubic function, or you could just type it in. It's going to give you the same exact graph. And as you can see the graph right here, the only thing that we get out of it, the only answer we get out of it is this real answer right here, which is x equals 3. So that's a real answer. So we know that an answer is x equals 3. And what are we going to do with this answer? We know that we could use synthetic substitution to plug it in to get a depressed polynomial, which will change it from a 3rd degree polynomial to a quadratic trinomial, which we'll be able to factor, split, and solve. Or if not, actually we won't be able to factor, split, and solve, but we will be able to use the quadratic formula. So let's plug in the 3 right there, and then let's make a list of our coefficients. The coefficient of x to the 3rd is 1. The coefficient of x squared is negative 7. Coefficient of x is positive 17. Coefficient, or the last one's a constant, which is negative 15. As you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. 3 times 1 is 3. As you go down, you combine. Negative 7 plus 3 is negative 4. As you go up, you multiply. 3 times negative 4 is negative 12. As you go down, you combine. 17 take away 12 is 5. As you go up, you multiply. 3 times 5 is 15. My remainder is 0. That does not surprise me because we found out on our Desmos app that it has the x-intercept of 3, which means that the answer is 3. So when you plug in the answer, the remainder is going to be 0. So why did I even do this? To get a depressed polynomial. And if it was a power of 3, it got a little weaker. That's why it's called depressed. It became an x squared. So we have a 1x squared minus 4x plus 5. Now this is an equation. They want all of the real answers, all the real roots, the real solutions. So I could set this equal to 0. Now you're not going to be able to factor it like what times what is 5, that if you add together is negative 4. It doesn't work. Now, if it would have worked, if it would have been factorable, on your Desmos app, you would have seen more x-intercepts. But you only saw one real x-intercept, which means that the other 2 are going to be imaginary. And this is why we're going to use the quadratic formula right here. The a value is 1, the b value is negative 4, and the c value is 5. And we're going to plug it all into x equals negative b plus or minus square root of b squared minus 4ac, all divided by 2 times a. And when you use the quadratic formula, please replace your b's and a's and c's with parentheses. So instead of b squared, you're going to put parentheses squared minus 4 times a times c, all divided by 2 times a. And now let's plug in the b value of negative 4, right? We got that b value right there. B value negative 4 right in there as well. Plug in the a value of 1 right in there and down there, and the c value of 5 right there down here at the very end. So that's our quadratic formula. And now let's simplify this quadratic formula. On the inside we have negative 4 squared, that's positive 16. So you have 16 take away 4 times 1 times 5. That's really going to be a 16 take away 20. If you're confused, use a calculator. But when you do 16 take away 20, you get negative 4. So your final answer is going to be positive 4 plus or minus the square root of negative 4, all divided by 2 times 1, which is 2. So when we think about the square root of negative 4, that's really 2i. That's really 2i. So what we really have is 4 plus or minus 2i, all divided by 2. So you could take the denominator of 2 and split it, do 4 divided by 2, which will be 2, and 2 divided by 2, which will be 1. So you get 2 plus or minus I, 2 plus or minus I. Or you could reduce all of them by 2, and you'll get the same thing, 2 plus or minus I. So those are your two imaginary answers. So for this cubic function, we really do have three answers. One of them's real. We got that from the Desmos app by finding the x-intercept on the Desmos app. And then we plugged it in to get a depressed polynomial, giving us a quadratic. Using the quadratic formula, we get these other two imaginary answers. Total of three answers, one real, two imaginary. Let's move on to the last part. Oh no, we still have 61 through 63. That's horrible. It's a long video. I apologize. So let's write this polynomial function of least degree with integral coefficients that has the given 0. So 61 is pretty easy because it doesn't have any imaginary values. It does not. See, what we're going to be doing is working backwards. What they're telling us is that one answer is x equals 2 and the other answer is x equals negative 5. So normally we would have a quadratic trinomial equation. We factor it to be able to split it with zero product property to be able to solve and get these answers of x equals 2 and x equals negative 5. Let's work backwards. We have the answers. Where did these answers come from? They came from a binomial that was set equal to 0. So to get that binomial, set this equal to 0, and you will have x minus 2. That's the binomial that if you set equal to 0, gives you the answer 2. And this other one, plus 5, you have x plus 5 equals 0. So this is the binomial that if you solve, set equal to 0, it'll give you the answer negative 5. So normally we split them, set them each equal to 0 and solve to get these answers. We're working backwards, so we're going to take these binomials and put them together and multiply them. So we have x minus 2 times x plus 5. We're going to set that equal to 0, but in reality we're not solving. We want the original quadratic trinomial, so we're going to distribute. So we're going to have x times x, that's x squared, x times 5, that's 5x. Negative 2 times x is negative 2x. Negative 2 times 5, that's negative 10. Combine the middle terms, we're going to end up with 3x. So your final quadratic trinomial equation is x squared plus 3x minus 10. Now you could put it equal to 0, or I don't know, the multiple choice might have it with the f of x in the front. Either way, this is the quadratic equation that if you were to solve, will give you these two answers. If you factor, split, and solve, it'll give you the answer 2 and negative 5. So that's when we had real answers, x equals 2, x equals negative 5. It gets a little more interesting when we have a real answer and one imaginary answer. Well, the real answer is easy, x equals 3. And we also have another answer, x equals positive 4i. And the complex conjugate theorem says if you have an imaginary as an answer, the complex conjugate is also an answer, which means that negative 4i is also an answer. So x also equals negative 4i as well as positive 4i. So on each of these, let's find the binomial where they came from. So if I subtract 3 on both sides, my binomial is x minus 3. That's the binomial that when I set equal to 0 gives me the answer 3, correct? This guy right here, if I set it equal to 0 and subtract 4i, it looks weird, but this is the binomial x minus 4i that if I set equal to 0, if I solve it, that'll give me the answer positive 4i. So the other one would be the binomial what? X plus 4i. If you set that equal to 0 and solve it, then you would get that answer above negative 4i. So the first thing to remember, if you have an imaginary as an answer, the conjugate's also going to be an answer. Split them all up, set them each equal to 0, and you have your binomial, and your binomial. Now they're all set each equal to 0, so we want to work backwards. We're going to use the zero product property backwards and put these binomials together. So the first binomial is x minus 3. I want to multiply that by x minus 4i, and then multiply that by x plus 4i. Now, when you do this, please begin with the complex numbers, with the imaginaries. Because when you multiply a binomial with its conjugate that has i's involved, the i's end up canceling out, disappearing. Check it out. if I go x times x, that's x squared. X times positive 4i, you can't really do that. Let's just rewrite it. It's going to be a positive 4i with an x at the end. And then let's now distribute negative 4i times x. You can't really do that. Let's just rewrite it. Negative 4i with an x. And negative 4i times positive 4i. A negative times a positive is a negative. 4 times 4 is 16. And I times I is I squared. And we should all remember that I squared is really a negative 1. So notice the middle terms are exact opposites. One's positive, one's negative. They disappear. So we really have x squared. And instead of a minus 16, you have a minus 16 times negative 1, which is a plus 16. So this is your new binomial instead of these blue binomials that we had multiplying together. Okay. Now we still need to multiply it by that first binomial, the x minus 3. X minus 3. So let's distribute that now. We're going to end up with x times x squared, that's x to the third. X times 16, that's positive 16x. Negative 3 times x squared is negative 3x squared. Negative 3 times 16, that's negative 48. Now we can't really combine the middle terms. They're not like, so you can't combine them. But the only thing we could do is switch them to get them in standard form from highest exponent down to smallest. And you need to do that, by the way. That's how it's going to look like on your multiple choice answers. X to the third minus 3x squared plus 16x minus 48. And that's it. If you set it equal to 0, that will be the equation that gives you the above answers. Or you could also put it as f of x or g of x. I don't remember how they write it, but this is what you need to identify right here. X to the third minus 3x squared plus 16x minus 48. If I were to have set this equal to 0 and solved it, however I could, I will get these 3 above answers. If I were to graph this guy, it would only cross at x equals 3. So if you understood number 62, you should be able to do number 63. So let's begin. What are the 3 answers here? We have x equals negative 2. We have x equals negative 3i. And also x equals positive 3i. So where did the binomials, or where did these answers come from? They came from the binomial that was set equal to 0. So I'm just going to write the binomial. What's my binomial that gave me the answer x equals negative 2? What would that be? X plus 2, that's right. Now let me jump over here. I'm not even going to set them equal to 0, but what binomial would give me x equals negative 3i? X plus 3i, thank you very much. And the last one over here, what binomial would give me the answer x equals positive 3i? X minus 3i. Okay, and what are we going to begin multiplying with? The x plus 2 or the i's? The i's, right? The complex binomials. So let's distribute there. We're going to go x times x is x squared. X times negative 3i is negative 3i with an x. Positive 3i times x is a positive 3i with an x. Positive 3i times negative 3i is negative 9i squared. And again, I squared is negative 1. And look at those middle values. They're exact opposites. They cancel out. I have x squared plus 9 left over. A negative 9 times a negative 1 is a positive 9. So there's my new binomial instead of these red binomials that had imaginary values. We still need to multiply that new binomial of x squared plus 9 times that x plus 2. Let's distribute x times x squared, x to the third, x times 9, positive 9x, 2 times x squared, positive 2x squared, 2 times 9, 18. The only other thing you could do is rewrite it from in standard form, highest exponent down to smallest. So you could put f of x equals x to the third plus 2x squared plus 9x plus 18. Or you could have even set this equal to 0. I don't remember how they do it on the final exam, but that's what you need right there. That equation, if you solved it, would give you the 3 answers, x equals negative 2 and also plus or minus 3i. Let's jump to the final part of this test, which is almost identical to the Chapter 5 practice test or actual test. So let's begin with option A. It's an even degree polynomial. Well, the even degree polynomials are either this one that has both n behaviors down here or both n behaviors up here. And it says it has 3 real zeros. So it can't be this one because it has 2 real zeros, and it can't be this one because this one has 6 real zeros. So option A is completely eliminated. Make sense? Let's move on to option B. It's an even degree polynomial function. Which one's even? Well, it's either this one right here or this one up here, either 65 or 66. All right. The function has two real zeros, so maybe it's this one. This one has two real zeros. Now let's just check the most complicated thing to check, which is the end behavior. It says the y values go down as it goes to the left. Do these go down as you look to the left? Yes. And then it says the y values go up as you look to the right. Do the y values go up as you look to the right? No. So B did not work either for any of them. Again, notice how I'm eliminating them. I'm going to the easiest thing to say. Like right here, it says it's an odd degree polynomial function. Which ones are odd? The only one that's odd is this one, right? So far, this is odd. Let's continue reading. The function has three real zeros. Does it have three real zeros? Yes, it does. 1, 2, 3. And last but not least, let's check the most complicated thing to check, which is the end behavior. This means y. The y values go where? The y values go down as you look at it to the left. Do the y values go down as you look at it to the left? Yes, it goes down as you look at it to the left. Do the y values go up as you look at it to the right? Does it go up as you look at it to the right? Yes, it does. So we have a winner right there, ladies and gentlemen. C belongs to number 64. Let's move on to D. D says it's an odd degree polynomial function. Neither of these are odd, so I could just scratch it out, right? E, it's an even degree polynomial function. Yeah, both of these are even. What else? The function has two real zeros. Well, this is the only one that has two real zeros. So let's check the end behavior here. The y values go what? Down as you look where? To the left or to the right? It says to positive infinity to the right. So they do go down as you look to the right. And the y values go down as you look to the left. The y values go down as you look to the left. That's true also. So that one works for, what number is that? 65. So option E belongs to 65. And 66, well, we already went through all of them. So that must mean that it's none of these, right? This has end behavior as the f of x goes to positive infinity as you look at it to the left. F of x goes to positive infinity as you look at it to the right. It has 1, 2, 3, 4, 5, 6 real zeros. None of these options have that stuff. So F must belong to that last one, number 66. Ladies and gentlemen, we've explained, I've done 4 different videos. This is the 4th video on this entire practice final. Practice final is very important because not only is it worth 12% of your total grade, but it could also replace one of your lower test scores. So please study, please ask questions, please get on Enmodo, check the videos, check the answers.